Hello and welcome to Neil's Retro Hobby Room. In this episode, I want to show you my new Commodore 128. I always wanted to have such a machine when I was young, and I never got one. And now I just bought one and I recently obtained it. But I have a problem, as you will see soon. This is a Commodore 128 that I recently bought, and it works, but I don't have a keyboard for that. Before I bought this, I didn't know that you actually need a special kind of keyboard. And the problem was that when I bought this, there was no keyboard included. And I thought, oh, that's not a problem. I will just buy one at eBay or somewhere else. But you nowhere get any keyboards for these machines. So I have this machine and I couldn't use it. So I went online, Googling and so on, and I found some solutions. And the first solution that I found, I think I have it here. Instead of using an original Commodore 128 keyboard, you can just use a C64 keyboard. And I have some of these. And this here actually works. And I, of course, cannot connect it directly to the Commodore 128, as you see here. So you have this connector here, that in the Commodore 64 you just plug into the main board, but the Commodore 128 has this nice connector here, which looks like a printer port, but actually this is a keyboard connector. And you cannot plug in the keyboard of a Commodore 64 into this. So you cannot directly connect this here. But on eBay, I found this connector here. So here you have the connector for the keyboard, and here you can connect the C64 keyboard. So you can just connect it like this here. And then you can connect this in your Commodore 128. But to be honest, this works, but it's not really nice. So we can try to connect this right now. I have to look how I can connect it. Yeah. So now it's in the machine. Then of course we need power. Here we have the power. And we need the screen output, so you can connect it using the same cable as the C64s. So here's the video output, it's here. So now I have this keyboard here. The problem is it is now, you see, it's not a nice keyboard, and it doesn't sit well on the table or on the Commodore 128. So when you type, it's not really nice, but it works. And to be honest, I have two other solutions instead of using a Commodore 64 keyboard. And I will tell you what solutions I have later. First of all, let's test this machine here. So let's first start the TV. Which takes some time. Here's the TV. Power is connected, keyboard is connected, and we have to switch it on. Where's the power button? Here it is. And there, as you can see, is our boot screen. And hello world, this works. So let's test it, print hello world, 20, go to 10, and then run. So this works. And now let's test the 64 mode of this machine. So the Commodore 128 has this version of BASIC here. And then it works in the Commodore 128 mode. But with Go 64, and then of course, yes, we want to go to 64. It works like a normal Commodore 64. And we can do the same. Hello world, 20, go to 10, and run. So as you can see, the keyboard of a C64 works, but it's really, that's nothing good. That's not good. It's not what I want to have with this machine. And I would like to use, for instance, a PC keyboard. And I found two solutions how I can actually use a PC keyboard. The first solution I found on eBay in the United States. It's a connector that you put into the connector of the Commodore 128, and then you can put a PS2 keyboard into this. But I'm still waiting for that. And then I thought I have different Arduinos in my basement, and I have a lot of electronic components. Why not try to build this on my own? And over the last 2 weeks, I have this machine now for 2 or 3 weeks, I worked on a PCB, or first I worked on breadboards to test my idea. And I will tell you about the details of the idea later when we are in the basement. But the idea is that I create my own PCB, or my own prototype PCB, where I have this Arduino, and the Arduino is able to connect a PS2 keyboard via a PS2 connector. And then the signals that the keyboard sent into the Arduino, or the Arduino reads from the PS2 keyboard, are then sent to the Commodore 128. And for that I created a prototype, and this is what I want to show you now. So let's go into the basement. I'm here now in my basement, and here on my back I have my prototype on 2 breadboards. So I have an Arduino here, I have my keyboard, my PS2 keyboard connected to this, and I can control some LEDs on these breadboards. And the idea is that the Commodore 128 has, you can say, a huge register of bits that go into the Commodore 128. Also on the C64 it has the same technique. And this register, every bit is set to 1. That means nothing is pressed. And when you want to send a key from a keyboard to the C64 or to the C128, you set some of these bits to 0. And my idea is that I convert from the PS2 keyboard via the Arduino that I have here, this small microcomputer or microprocessor here, and convert the keyboard keys from the PS2 to these values that the Commodore 128 understands. And this prototype here is with some LEDs. I just start it up now. And then when I press the up or the down keys, I can change, you will probably see only some lights here shining or flashing. I can change the content of the register. And I designed this in a way that I have a 25-bit register, and I can connect each bit of the register to the input of the C128 keyboard. So I have this connector here, and this connector is a printer port or a DIN connector where I can connect the Arduino or the PCB that I created to this connector, and then this connector goes into the C128. And then when I type on my keyboard here, then these get converted by my PCB, and I have the PCBs here. So I just received these PCBs here today, and on this PCB I have some shift registers and I have some latches. A shift register, you can put in bits in a serial way. So you can put in, for instance, a 1, a 0, a 1, a 1. And then the shift register puts out these values in parallel. So you don't get a single 1, a single 0, a single 1, a single 1. You get 1, 0, 1, 1 at the same time. So on the top here of this PCB, we have all these connectors. And these connectors then go into this here. And today I want to solder this here, and I want to test if my breadboard design that I extended using a CAD software to create this PCB, and if this prototype actually works. So I want to solder this here. I want to put some shift registers or shift chips, logic chips on this. I want to put the latch chips on this. I want to put these the Arduino onto this. And then I want to test if I can use my keyboard to count up the LEDs that I also will connect to this board here. But first of all, just let's solder this board. Let's put some sockets on this, and let's put some ICs, some logic ICs, and the Arduino and some pin headers on these. So here's now my designed PCB, and I want to start with a pin header here. This will be the pin header for the keyboard. I have my soldering iron here, and it's hot right now, so let's start soldering. And I just hold the piece I want to solder. One hand. And start with the first pin. Then I can press it. So I want it. And solder a second leg. The first leg. Let's have a look if it's okay. Yeah, that looks good. Press it a little tighter to the PCB. Now it's good. Now it's good here. Now let's solder the remaining legs. So this was the first pin header. Looks good. So let's go on with this pin header here. This is the pin header for the keyboard itself. Pin, and let's tighten this a little up here, so it's better, and let's move this a little. Okay, this looks much better, so let's solder the remaining pins. Second pin header, and now we have two pin headers here for our Arduino. okay. There's one solder joint there. It's not very nice. That's okay. So now let's put in the sockets. These ICs are all LS74 logic chips. So as I said, I have here 3 shift registers, and these are all latches. So the data word will be shifted through these chips here, and then the latches here are responsible for outputting the actual or the current data word that then will go to the Commodore 128. So I have now here all these capacitors. These are the bypass capacitors that I also want to solder now onto the PCB. And then I want to get the needed chips, the ICs. And I will then make a break of the video, then populate this thing here, and then test it together with you. So this is our PCB. Finished soldering. But what we still can do, we can clean this up right now. So I have some isopropyl alcohol here. And I want to clean it up. So let's remove this dirt here. The remaining parts of the legs. Okay. Let's get some alcohol and clean this. Here we have IPA and a brush. This one. Let's get some alcohol out of here. And then we can just clean the PCB and remove the flux from the PCB. Okay, I don't think that we have flux here. Okay, so I will now make a cut and then come back when I put all the chips onto the PCB. So I populated all the chips to the PCB, and meanwhile I also had a look at some things and I realized a few things. First, I do not need so many ICs here. So I had this 8-bit shift registers here and the latch chips, and I realized by searching online that you can find an 8-bit shift register IC, a logic IC, a TTL IC that has actually the latches here inside. So instead of using all these chips, I could have used only 3 of the shift registers with the latches inside. Then I realized that the Commodore 128 keyboard connector has not so many inputs as I thought, but it uses inputs and outputs. So it puts out some values, these go to the keyboard and then come back and get changed by pressing on the keys. And when you press no key, all the values that come back are ones or high signals. So the lines are set to high. But I do not need the outputs from the Commodore 128. I think it's enough for me to just set in the inputs based on the keyboard here. So I could also change this and probably could live with only 1 or 2 of these shift registers. So I will probably redesign this here and use a lot of or much less chips than I used here. And I want to try this here. And this here are 8 mega or 80 mega 8 chips. These are microprocessors that are easier than this NodeMCU, and I could use one of these probably. So the PCB will probably shrink to this connector here, fewer lines, only 1 or 2 of these shift registers that I have to order, and these 8 mega 8 chips, 80 mega 8 chips here. But right now, I want to try if the idea with these connectors going to the Commodore 128 actually work. And to do so, I will use this here. And now, as I build this, let's test it. So when I switch on the power, you can see that all the LEDs are now set to high value. So this is initialized by the NodeMCU, and it also reads from the keyboard here. And when I press a key here, I can change the output number that I get in my output register. And when I go in the other direction, it counts down. So this works. So the next steps now will be to connect this actually to my Commodore 128, only using a few of these connectors. I want to use this here for that. So I can just put cables to this connector and then put this into the Commodore 128. And it should work then with my keyboard. Of course, I have to program the NodeMCU that it knows when I press a key here, what it has to send out to the Commodore 128. I will build this and then I want to show this in one of my next videos. This is the end of this video. I hope that you find it interesting how I try to build this connector. So as I said, I'm not an expert with electronics. I'm more the software guy, not the hardware guy. But I think as a first start, this is okay. So my self-created PCB works as I designed it. So I'm quite happy about that. I realized that I can maybe ease it down. So remove some of these chips, as I said. So that's probably what I will do in the future. And as I said, I want to test it with my Commodore 128. So I will probably in the next days or weeks program it so that it actually puts out the correct binary values to the Commodore 128. And yeah, this is the end of this video. So if you like what I'm doing, consider subscribing to this channel. I would be really happy if you do so. And if you like what I'm doing also, please give a thumbs up. If you don't like what I'm doing, you know what to do. Give a thumbs down. And yeah, thank you very much for watching and see you in the next video.